live. Good morning, everybody. Good afternoon, good evening. Another one of my Fiat clumsy live streams. Okay, let's fade that down. And we are ready to go, I think. Okay, so the clickbait title is Pimp My TrueSDX. What are we gonna do today? Let's have a quick look. Here we go. So basically 3 potential mods that we can do. Number 1, and probably the most interesting one, modifying T2 as suggested by Manuel himself. This is a post in the forum, dl2man.de. It's pinned at the top of the troubleshooting board index, so you can find it easily. So basically what you can see is T2 heats up a little bit when we are transmitting. And the fix for that is to increase the inductance of T2 so that we are basically not losing any power. I actually had a look. There's this very useful web page, torroids.info, where you can basically click and select what toroid you are using. And then you can enter the number of turns, and it gives you the inductance. And we can do that for 7 turns, which gives us 17.15 microhenry. We can do that for 21 turns, but now I've switched to the wrong view. Yeah, that was clever because because I was an idiot and put my hotkeys on the numbers to switch between my scenes. So when I enter 21 now, you're immediately switching the views. So that was clever, wasn't it? Anyway, I've already done it before. Starting the stream. Just want to show you how to do it yourself. So I'll just show you my notepad in a second where I've scribbled down the results. So yeah, for 7, 14 and 21 turns, I calculated the inductance. And then you can find somewhere on the internet calculator for RL high pass filter. And you can basically enter your inductance here, and it gives you, I think, the -3 dB point. We will see in a second when I go to the workbench for the 3 different windings, 7, 14, 21, the microhenries, and the -3 dB point of a RL high pass filter. So if that doesn't make any sense to you at the moment, let's have a quick look at the schematic here. So this is basically the SWR measurement bridge. Can I draw here? Let me find pencil. Yeah, in theory I should be able to draw here. Does it work? Okay, so basically, what is ANT here? Antenna. That's the output of, the TX output, obviously. So it comes from the relays. Depending which band you're on, the right toroids are switched in via the relays. So, this is where your TX power goes through via 1 turn. And on and out, you have basically, I'm drawing this with the mouse, it looks awful. Basically, you have your antenna, but what you can also see is that you here have the coupling transformer T2, and one side is connected to ground. So what we basically have is what I've just shown you in the previous picture. You have, you have here R, Right, look, not very good at drawing. Let me try again. Hang on a second. Control Z. Right, so we have the R. And we have our L to ground. And here it goes to your antenna. So yeah, what you can basically see, if the inductance is here too low, then we will lose a bit of our TX power. And that's why, let's go back to the web page. And not this one. Let's go back to the original posting. That's basically why Manuel suggested, okay, we go from 7 turns. So 1 primary, 7 secondary, to 3 turns primary, 21 secondary. The caveat or the catch here is that he says here the 0.5 millimeter wire would end up too tight. So basically the complete inner space here of the toroid is filled, and you have problems winding it on. So what I'm wondering is basically, do we really need 21 turns, or are 14 not enough? So I'm thinking I might try this with 2 turns primary and 14 secondary, and try to go with a 0.4 millimeter or 0.5 millimeter wire. I don't know if it fits 0.5. It's 14 turns. Well, we'll see. So that's one mod we can do. And the result is, here's the thermal image before. Probably, I don't know, something around 25 degrees. It's not super hot, but you can clearly see that we are losing a little bit here. And then after the mod with the 3 turns primary, 21 secondary, it's basically you don't even see it anymore. Everything good. So the second potential change we can do to pimp our trusdx is the OLED mod. As you all know, the OLED is a bit dim, and there's another posting in the forum. Go to general information, OLED display. And a very nice mod by WA2T. Basically, instead of powering the OLED display from the 5 volt, he's taking here 12 volt through I think it was 8 volt LDO. So basically we get 8 volt out, and we power our OLED display with 8 volt, and the result is obviously that it's brighter. I think there's a picture down below. Yeah, here you can see it. So this is the before and the after. So that should definitely help a little bit. I mean, probably not in bright sunlight, because I mean you cannot see a OLED display in bright sunlight, but it will definitely help. So the only tricky bit is that I basically soldered my OLED display in. So getting it off is the catch. And then the mod should be fairly straightforward. And here's another trick. The problem is, of course, when you power the OLED display with the 12 volt rail, then it won't light up when you connect the transceiver only via USB, because the USB only provides 5 volt. So the trick here is to insert a diode here, so that the plus 8 volt, when it's powered via the 12 volt power connector, doesn't make its way, back to the 5 volt rail and, fry your OLED basically. So a little diode there, and of course you can then say, okay, use a Schottky diode, because your regular silicon diode, you lose 0.7 volt. So from 5 volt, 0.7 volt lost, and then the display will be even less bright. I don't know how much difference it makes. So with a Schottky diode, that should probably work better. Again, here it's a fairly straightforward change, so I don't know if you're interested in seeing me do that, but I'll do it on my machine. So yeah, here's a A/B comparison, before, after, but of course, you know, cameras and white balance. So, I mean, what you see, it's relative. I mean, if this is with a fixed, recorded with a fixed ISO setting, then you definitely see it's brighter than before. Yeah, and here's a bit of a different change from somebody who used a bigger LDO, the silicon diode. So yeah, I think that this mod is fairly straightforward. You just have to, you know, hook up your LDO, maybe give it a small capacitor to ground so that it works properly on the output, and that's it. Okay, and the third potential change that we can do is, and this looks really nasty, is sorry, I'm not complaining to Marco who did the mod. It's just very difficult to get the right capacitors with the right size, and I'm having exactly the same problem. So my mod, if I do it, will probably look as nasty as this one. So what's the problem? The problem is the 470 nanofarad capacitors, and yeah, ceramic capacitors are quite microphonic. So I think on at least my trusdx, what I see is that occasionally it goes in a funny state where some, I don't know, feedback loop resonance or overload, or I don't know. And then when I bang the machine hard on the desk, it somehow, you know, recovers. And that's a clear sign that somehow there's some coupling of, I don't know if it's the audio output or that couples into the ceramic capacitors and it gets a feedback loop, or I don't know. Anyway, what I'm trying to say is usually for audio signals, you should not use ceramic capacitors in your path. You should use film capacitors, polyfilm, or yeah, plastic basically, right? The only problem is that you cannot get them. I mean, the footprint on the current trusdx PCB is made for ceramic capacitors, and the film capacitors are much bigger. And I ordered a bunch from eBay, but I think they're even bigger than this one. So I'm not sure I can do the mod right now, because I got 470 nanofarad 100 volt, and I think the height is too high. I have to see. I think they're almost, I don't know, there's not 5 millimeter high, but 4 or so, and I don't know if I have enough gap between yeah, the main board and the RF board. So I already ordered a second bunch of capacitors, which are 63 volt, which should be a bit slimmer, and in the end they'll probably be exactly the same size as on the picture here from Marco. So right, here's a different mod. Somebody used, I think, was the tantalum capacitors, but yeah, it also does look, if it works it's fine, but it does not look super nice, right? Yeah, maybe on the next PCB revision a little bit more space would be good. Okay, so that's basically the theoretical part of this stream. Let me check if anybody's watching. Yeah, nobody's watching as usual. Haha. Top chat empty. So I guess I can do whatever I want. And I think I'll do the T2 mod. And then let's see how long that takes. But I guess that will be already enough for the stream. So let's switch to the workbench. And a little caveat. The setup looks different now. A complete different streaming machine. No longer the laptop, but a proper desktop powerful Ryzen machine. But the catch is the PC stands next to my shack, to the HamRadio transmitters and so on. So I cannot just grab it and put it next to the workbench. So unfortunately, that means the video is at the moment streamed via WLAN. Wi-Fi goes over Wi-Fi to the streaming machine, and the streaming machine then streams to YouTube via Wi-Fi. So there could be overheating issues of my mobile that is being used as a camera. And I also don't know if you're bandwidth limited. So the image quality might not be as good as with the previous streams, but yeah, this is what I can do at the moment. Okay, I guess I'll switch the microphone then to the lavalier mic and get up, move to the workbench, and we'll have a look to do this T2 mod. Okay, clip on the microphone. 1, 2, 3. Okay, I see the bar graph moving. So, right. So first of all, I promised you I've written down the microhenry values. So 7 turns gives you 17.15 microhenry, 14 turns 68.6, and the 21 turns gives you 154.35 microhenry. And if I put that into this online calculator, then the minus 3 dB point is for 7 turns at 464 kilohertz, for 14 turns 116 kilohertz, and for 21 turns it's 51.56 kilohertz. So I guess it's is that quadratic? Probably. So I'm thinking maybe 14 turns are enough, because we already go, or almost a factor of 4 by doubling the turns. Anyway, let's see what wires I have. This one came fresh from eBay. Haha. And should be, in theory, 0.35. So let's have a look. What do my blind eyes tell me? 0.35. So that one will definitely work for the original mod suggested by Manuel. And then I probably have other stuff here in my tray of old wires from various hobby projects. What is this? This is 0.5. That might be, I don't know, does that work with? It's 14 turns, it might work, I don't know. And what else do we have here? So this one is also 0.5. And this one also 0.5. I think somewhere I still had a 0.4 here somewhere. Maybe is this one? Let's have a look. Yeah, that's 0.35 as well. Okay, so basically we have two options. Let's see. in a way, a bit thicker wire would also not bad. I mean, basically, where it goes to ground, if the inductance is big enough, we don't have to really, I mean, it's not, what do I want to say? The RF power is not going through it, yeah? So maybe a smaller one with 21 turns is perfectly fine, because it's going to ground. I mean, we are not transmitting through it. There's an easy formula how you can calculate your RL filter, but I didn't look it up. 1 divided by 2 pi RLC, whatever. I mean, find it in any engineering book. So, but I was lazy, so I took the online calculator. What would have been, of course, nice to check what is the how much loss do we have at 3.5 megahertz? Yeah, so the lowest possible transmit frequency. So okay, good. So in order to do this, it would be maybe a good idea to first see what we get as an efficiency at 3.5. So here's a small dummy load. Let me write it down. So CW and go to 3.5. Okay. I always had problems with 80. So as you can see, I could get the power up, but the efficiency is not super great. So let's see, what is that? At the moment, with 1 turn to 7 turns at 3.5 megahertz, we have around 70. And now it heats up, maybe gets lower. Yeah. Yeah, something around. Is it getting hot? That's also the question. Oh yeah, not so bad. Anyway, I'm here in my shack under the roof, and probably the whole room is heated up at 30 degrees, so I wouldn't even realize if... Yeah, I don't know. So it's 73, between 72 and 73%, I would say. Good, so let's take it apart and take it apart. First take the button off, take the screws out. Yeah, and here we have the, I forgot to show you, here we have the nice 470 nanofarad capacitors, but they're all 4.4 millimeters high, so we'll just find out in a second if they even fit between RF board and main board, apart from the fact that you have to do a bit of a botch with the wiring. I mean, in theory, they're all just, I mean, connected to ground, so you can hook one side of all these capacitors together, and the other side you need a bit of creative wiring. Okay, now we need the screw. Oh yeah, as you can see, I managed to print the case, but it's not perfect yet. Well, my blue case, I told you I have a blue problem. Everything has to be blue. Oh god, and it's very tight. So that will be fun getting out off again without yeah, that needs a bit of force. Okay, and the other side. Should have dismounted it before the stream. Yeah, but now it's can take it apart. Okay, so yeah, here quick peek at my come on, I want to focus, but right, double tap for focusing. Yeah, here you see how the PETG print came out. Not super nice, but as good as it gets at the moment. Here I have this line where the tape that I used on the base plate joined, but yeah, I don't know. Maybe I spend some money and get Siraya blue for the resin printer, and then I print it on the resin printer and then spray paint it or something. Okay, good. So let's take the RF board to the side. Time to wear my ESD wristband. I should probably have worn it before. And let's get the okay, so basically these I have to focus again, otherwise it won't be sharp. Let's see. I hope that works. I could also zoom in maybe a bit. Not sure how that looks like. Maybe. Right, so soldering iron on and solder sucker. Can I do this without? Oh yeah, here, by the way, here's my, no, you can't see it. Here are my 8-volt LDOs for the OLED mod, just classic through hole. Okay, then let's see. Do we get this out here? That's probably not so easy. Maybe I should pull from the other side. Let's get a bit of maybe I get yeah, see, I was very careful soldering it. I think I soldered the transformer also on the other side, so now it's Not so easy to get it off with the solder sucker. Let's try to pry the one turn off. Oops. Nope. I'm not sure. Can you see what I'm trying to do here? Probably not. Okay, let's do it differently. Let's try from the top. Let's go there and pull with the... Yeah, that is better. That was the one turn in the middle. Try the side here. Maybe that's, yeah, that's the one that goes to ground, right? That's why it's a bit difficult. What does my soldering iron say? 350 degrees, maybe a little bit higher here. If I pull, then I will rip the pad and the wire out. I don't want that. Okay, let's leave it for the moment and try to get the other side out. So this is the one turn. There we go. And then this is the, that's also easy. And then the one that goes to ground is a bit reluctant. Guess I should put the all-purpose solution for all these problems. More flux helps for everything. And proper contact. Yes, come on. Maybe I go a bit higher in the soldering iron. And yeah, this is what I could do is as well is to cut it off. Then I'm not heating all my wire at least, and can focus on the right. That's not so easy, but now we can try with the solder sucker. And maybe try from the back side now as well. Yeah, because that's also going to ground. See, that's why this one is a bit tricky, because come on. Yeah, I think I can go. Maybe I should also use a different tip, not the one with the dimple. That is good for SMD. Let's try this one. The good thing is the JVC station that it takes you 10 seconds to change the tip. I hate this, you know, when you have to use a pliers or something to unscrew, and then is that better? Yes. Okay, well, we got it out, but of course to get it newly wound in, we would need to get the hole to open up. Let's see if that works. Oops, yeah, it works, but should also fix it on the other side. Okay. So that was number 1. You can't see it. Should make sure everything is in frame. And problem is that I cannot suck straight because the camera is in the way. Give me a second. If I can hold that straight, the solder sucker, it should be easier to get the holes to open up. But of course the tricky one is again the one which is connected to ground, so heat it up, and yeah, that will be a bit of fun in resoldering the newly wound toroid. Let's see. Let me try the braid, if that works better. It's already used on the tip, so get that off. More. Yeah, so see, this is the only tricky bit here, to get the old toroid off and not damage the PCB. So, that looks promising. Okay. 2 holes opened up. Let's try from the top now. This takes a bit patience. But at least my camera is still working. Famous last words before it shuts down. So. Let's get a bit of, don't worry, we clean it all up with isopropanol afterwards. Yeah, so the question is, again, should we do 14 turns or really the 21? I guess it doesn't harm, because if the inductance is high enough, then nothing will anyway go to ground, so it won't heat up. So we might as well use the 0.35 millimeter wire in the 21 turns. So at some point the cat might show up, but then I have to quickly close the roof window because she likes to climb out there and visit the neighbors. I'm in a terrace house here, so she climbs out here, and the next open window she climbs in, and all my neighbors get a heart attack when suddenly a wild animal makes its way through the living room, or I think, I don't know, still not super nice here with my wire, but we can make a quick test. Let's see how bad that enameled wire is. Is it okay to burn off the enamel, or? Yeah, that works beautiful. Look at that. Can you see it? No, you can't. Once again. Yeah, let's try again here in the middle. I don't think you can see it anyway. Yes, but okay, yeah. Camera is too crap. But basically, soldering iron at 370 degrees, you can burn off the enamel without problems. And I thought I use this end to open up the hole, but no, it does not really work. Good. Sorry for that, but that's the catch with the live stream. How do I get this to open up now? Well, if in doubt, add solder again and suck it. And did that work? Yes, it worked. Okay, so 1 out of 4. So feel free to fast forward. But if you try this mod, you might get into the same issues I'm having here. There's also, I think you can get a cheap electrical solder sucker. A lot of guys use it, like for refurbishing the 8-bit computers, and it also seems to work pretty well, but so far I did not go for one. Good, 2 holes open, I think getting closer, and we also managed to open up the one that goes to ground, so the tricky one is already done. Yeah, now we are getting where we want to go. So, and if we are lucky, nope, we are not lucky. The last one is a bit. Yeah, I was wrong. This was not the one going to ground. The trickiest one is not opened up yet, but we'll get there. Patience. So, of course, we are frying around here, so the silk screen is also deteriorating rapidly, so you don't want to do this more than once, I guess. Yeah, here you see, this is the one that is missing, where maybe I can get it with a solder braid. Nah, it's stubborn. Let's try with the okay, I think this one will be a bugger. Yeah, that's not It's not good, but I think I have to come with the readily wound toroid and heat it up and then push. Otherwise I won't get it. So let's clean it up and start winding the toroid. Otherwise I'll be here all night. I need something to clean. Oops. Okay, so paper towel. And here, well, it's contact cleaner, but I think it's basically the same. More expensive version of IPA, basically. So, let's see. That was the top side cleaned with our ground connection still with a closed eye. And the other side is also messy. Good. So now onto the toroid. We put this aside for the moment somewhere, and then let's untangle the 7 windings of the old transformer. Okay. Nobody watching, but it's my meditative Saturday evening task here, so slight scrub, because there's also a bit of flux from the soldering on there. So here we have our shiny new toroid, and then in theory I could look at there's a web page that says how long a wire needs to be for 21 turns. I have no idea. Can't be. I think that should be plenty. Anyway, I got the wire really cheap. It was like 50 meters for €4.50 inclusive shipping, so I can't complain there. Let's see if that is enough, and try to wind the 21 windings. So now you see how I do this. I think the start is always the trickiest one, because at least I want to have it tightly wound around the core and not loose. So yeah, see, that's already not very tight. So a bit of pulling force. Okay, what I could also do is, wind a bit more, and once, 1 or 2 turns more, and then take the end off at the end when everything has. The question is, how is the focusing working at the moment with this? Let's see. Autofocus, continuous. Maybe that is better. Yeah, like this. Yeah, I think. Yeah. So, how many turns do we have? Already 3. So in theory, you could already say these are the
3 turns we need in the middle. And yeah, you also see my torroid here has a bit of a ding, so it's probably not good. Let's see, can you see that? Probably not. But I mean, both toroid T1 and T2 should be the same, so that little scratch here is probably also not good for measuring accuracy. So that was 3. 4. 5. 6. 7. Okay, so now let's see. It's more or less a quarter. So I guess when I add another 14, I'm like 3/4. Okay, so yeah, I think it's good enough from the spacing. Can shift things around at the end. So number 8. Nine. 10. 11. Yeah, I've already got a feeling that I'll need 1.5 hours for this. And nobody will watch 1.5 hours of me winding a toroid. So feel free to fast forward when I try to get this back into the PCB. And now I lost count, but that's not a problem. You anyway should double and triple check everything, so let's do that. Let's use this one. Is always good for figuring out how many turns do we have. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13. 14. 'Yeah, so space it out evenly. 15. 16. 17. No, go through 18, and this number 18. Not very tidy. It's my winding. So. I'm not super happy with this. I must say, at the beginning it was okay, but now it's a bit loose. But if I restart again, I've lost any last viewer that I have. So, oops, yeah, that was the punishment for the impatient. See, it happens to everybody. And we've successfully ripped the wire because we became impatient, or I became impatient, which means we'll have to do it all again. But in order to, oops, see, that was the comedy moment everybody was waiting for. But now the wire is ripped. Yeah, that's a catch with these things. Yeah, if you don't pull strong enough, the winding will be loose. If you pull too strong, then it's broken. So yeah, well, okay. Anyway, I've never used this wire before. Oh, look at that, and it even rips when I unwind it. So maybe I was already pulling too strong. Good. So fresh start, second start. Let's do the 3 windings first. I should have done that at the beginning as a test. So let's see. So how do you count windings? Every time you go through the center, it counts as a winding. So we already have 2 here. But I guess everybody who built their own TrueSDX knows the fun of winding toroids. It's not difficult. Just need patience and not rush it like I did. So, how does that look like? 3. Good, that's now too short for the 21. So into the bin. So yeah, that's our 3 inner windings, and now we have to do the 21 a second time. I forgot something. This would be fun, yeah? I think we have to check in which direction I have to wind it, because I mean for the inner one it's not important, but I think, how do we do this? Yeah, I think I've already done it wrong, because if you put it there, I think it's okay. So when we wind like this, we start here and we come out here on the other side. Let's see. Yeah. So I should start, oops, not. So like this, yeah. Start from this side. Oops, and again I'm out of focus. I really need a monitor here in front of me to know that everything is in frame. Okay, let's try like this. And again, the first 2 or 3 windings are the tricky ones. Yeah. Patience. Don't rush it. So now we can pull this a bit tighter, but not so tight that it rips. See, this is what I don't like. So okay, let's put this away again, and second try. So the 3 inner ones are done, and 2 so 1, 2, 3. 4. 5. 6. Okay, I wouldn't need a ESD wristband for this action, haha. So that was number 7. Interesting. Number 8. Nine. 10. The interesting question will be, will we see increased efficiency? 11. Twelve. 13. Ooh, that was dangerous. Almost ripped. And 14. I think we can space it out a bit more. Okay, another 7 to go without ripping the wire. And number 1. 2. 3. I wonder how they do it for the commercial radios. Do they have a machine to wind those toroids for the ATUs? Or is there somebody sitting there and really doing this manually? I guess they have a machine, or? And now I missed count again. I shouldn't keep chatting. Okay, anyway, there's probably at least 3 more to go, and then I count. Probably 6 more to go. 1. I'm also wondering what all the other guys set their streams to. I'm always torn between education and entertainment. So when I mess up, it's more entertainment. When everything goes well, then it's education. I don't know. But probably more entertainment than education. Because half of the time don't know what I'm doing either. So okay, so time for a count check. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh. One more and another safety count, because you should really get this right. It's easy to miscount. Another trick is to, if you are unsure, take a photo on your smartphone, then open it, and you can use I don't know, a marker and pen basically, and yeah, if you zoom in, it's much easier to count, and you can also scribble with a text editor. Well, actually, in theory, I could do this right now if the whiteboard app would still be working. I think I've moved to the new machine, and I have not installed the whiteboard app, so I could not, scribble and do counts. So let me manually count once more. So
1, 2, 3. It's difficult like this. Let's try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yeah, I think it, oops, should be okay. Now we can, I mean, it doesn't matter here. This is just the ratio is important on this one. But here, for example, I think you messed up here in the middle a bit. What did I do there? See, there's something wrong. Of course I messed up in the middle, because this is the show effect. Haha. Yeah, that's why I said wire almost ripped, but I think I made a mistake and did. It's not. It's a bit loose, and I think I wound one wire on top of the other here. Can I fix that? Not happy with this, I must say, because I'm a perfectionist. Well, I try to be, and I'm my own worst enemy, you know. Try to be perfect, and then things get worse and worse. This is a curse, I tell you. Always want to do things neat, and while doing so, mess up really bad. Okay, yeah, well, what can I say? This one winding here in the middle looks a bit dodgy. But yeah, this is not good. Should I wind it a third time? Then I've lost any viewer that I would potentially had for this video. That's the catch with live streams. Meh. It looks shit. Does it? No, I think it cannot zoom in. Right, what do I do? I have no intention whatsoever to take it, put it in, take it out again, and put it in again. So I guess we'll wind it a third time. 3 times the number. And let me check, since anyway nobody's watching here. You can just fast forward when I grab the PCB again and try to put it in. So sorry for that, but the Sheldon Cooper in me does not want dingy torroid windings. So I'm just costing YouTube memory here for the world's most boring live stream. Wasn't Dave from EV Blog suggesting that? Do a few really boring ones to push your average down and then do the hit video. Unfortunately, I only can do bad videos, so bloody hell, this is not good. Okay, but what do we know now? At least we know now that
about that much wire is enough for our 17 turns. So you can cut it a bit shorter. Let's see, maybe like this somewhere here. And on to the third attempt. Mind you, this is a bit, yeah, as I said, this is a bit thinner wire than it originally came with the TrueSDX, which was 0.4. So maybe that's why I'm not used to it and mess it up. So let's try again. In which direction do we have to wind it? Same as last time, but this time perfect, please. Okay. So. I need a bigger desk. This workspace is very small since I don't know, since 1 year I tried to buy some cupboards for the workshop here, you know, nice metal ones, metal drawers, like these DEMA cases, which can, I don't know, each drawer can carry like 30 or 40 kilograms. You can put heavy stuff in and they look nice, and I'm not managing to buy this stuff. Don't know why. I'm researching it on eBay and I have it looked up, and then it's like, okay, 2 of these and shipped with the lorry, and then I need somebody to help me carry it up in the workshop, and yeah, something always stops me from hitting the buy button. So the workshop looks like a complete pigsty, as you have seen in the intro, where I had a picture of the cat. And this is how the whole thing looks like. And lots of moving boxes full of crap either, because I dismantled one half of the workshop and didn't manage to buy the cupboards, shelves. So now I should shut up for a moment, focus here on the winding. So we are at 4 windings. So let's try to do them perfect. Does already not look perfect. So how many do we have now? Quick check. $13. Looks better now, I think. 3 times the charm, 3 times lucky, I think you say. So now just have to finish exactly with 21, but that already looks much better. I'll give you a macro shot when I'm done. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 2 more. You really cannot rush this. Of course I rushed it. So that was number 20. And 21. Hooray, hooray. Here we come. 21. Good. Then space it out evenly, but as I said here, it doesn't really matter. That's just my compulsive behavior. I'm not knocking 3 times on doors, but almost. So let's see. That does not look too bad. Good. Then final check. See, that's why we should really do the, let me see if I can zoom in here, and you also have some fun. Can I zoom? Yes, I can zoom. Does it also focus? Of course not. Let's see. Hello. Maybe do the tab focus. Yeah, I think now you can see it. And you can tell me after watching the video that I miscounted. But I'm cheeky and I will use some help to figure out if I miscounted. Give me a second. Slide off screen, double test check. Yeah, I really prefer the take a photo, and basically what I do, take a photo and I put a dot with some graphics program on every winding, and then you basically just, yeah, you're sure what you've done. So final test. And you think this might be a bit too picky to double and triple check this, but I mean, you really don't want to miscount and then go on a merry goose chase why things are not working. I mean, on the trusdx, I mean, if you got one turn too much or not, I mean, you will figure it out at the end when you tune it with a nano VNA, but I think you should really stick to the winding numbers that Manuel came up with. So let me count, and then we try to put this in. The one hole which is not open is a bit annoying. I'll have another go at that in a second. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, well, in theory, that looks okay. And the middle one is 3, obviously. That's easy to count. Good. So we can cut this leg off. We have our new T2 transformer. And then let's have another go at this stubborn hole. And yeah, I somehow bought lead-free solder for everything, which was maybe not such a brilliant idea. Let's try something else, I guess. Let's try to go to 380 for the temperature on the soldering iron. And have another go with the solder sucker. Maybe maybe not. Bloody hell, this is not easy to. Now, are we open? Or are we denser? Hooray! We've managed to open all holes. Fantastic. Good. Then let me show you how I do this. Basically, I sort my wires. Somebody is maybe shouting now that I'm putting it in the wrong way. So this one is the 3. Oops, not like that. That would have been a short circuit. Let's do the one, have the one in the middle with the longer leads and the 21 windings with the shorter leads, because then I can put them in like That's not too bad, I think. Why does it look odd? Because, yeah, well, of course it's a bit cramped now because it's not a straight line now between the, you know, before it was one turn and now it's 3 turns, so it will sit at a slight angle. How do I do this? So this goes like, yeah, that's yeah. Good. Then everybody does this differently. The way I do it is I cut my leads right now. Of course, that makes it more difficult to put them in a second time. But now I can take this out again and just burn off the enamel. Let's take oops, not like that. And is my stream running? Maybe it's already crashed and I don't know. So let's burn off the enamel by a few millimeters. So, and the other side. And here. Okay, I guess we can go back to lower soldering iron temperature now. Scrape off the black bits a bit. So this is yeah, now we just have to be a bit careful if we insert this again. So the benefit of doing it that way is that you can look from all sides, and here on this side I think I need to give it another yep. That looks good. My camera is so bad that you don't really see it. I should really get one of these USB microscopes. Then the picture quality will also be much better. So now you have to put that back in to position. So these two are the middle ones. This is the bit which we should not get wrong now. So these. Oops. Putting that in and showing you at the same time is tricky. Come on. This is of course easier when you only have 2 wires to put in. With 4 it's a bit of a challenge, but I think we have it in. Let me check. So this is the end. Looks good to me. Okay, now let me tack it quickly before it falls out again. I'm going back to 350. And where did I put my solder? Somewhere, far, far away. So let's, now let's solder the ground line with 380, because that's the tricky one, and the rest should be easy. You can't see it. Okay. I'm holding the toroid with the thumb, that's why I have not put it into the... Okay, well, it's not perfect, but it's tacked, and that means now I can put it into the holder and we can also give it a bit of flux. So, and then we can go back to 350 and solder the bugger in. We could also pull a bit with the pliers. Yep, to make sure it sits flush. That was not bad. And let's try this one. Oops. No, I didn't rip it. That would have been fun. And as I said, it's lead-free solder. That's why it gets dull almost instantly. And number 4. And let's also reflow the one that goes to ground. How does that look like? Not so great, because it... Oh yeah, it's okay. It's okay. Let's just heat it up once more. 1, 2, 3. Yeah, this is the one that goes to ground is always a bit trickier. So if you solder your toroids in, the one leg that goes to ground needs a bit more heat. Okay. Now let's look from the top. Should we also solder it from the top? Well, I think we are a bit maybe here, that one that goes to the ground. And I'm left-handed, so that's why it all looks a bit strange. Okay. Should we put... Yeah, that side looks okay. The other side, I was a bit too tight with my... Yeah. More goo. I pulled too tight, so the idea was that there's also a millimeter or so wire where the enamel was burned off on the top side, so that you can also solder it in from the top, but I should not have pulled it. I think the one, yeah, looks okay. And obviously the side where the trace goes away is the important one. So let's see this one. Yeah. That one on this side I'm not super happy with. Don't know. Can we pull a bit here or push a bit? Let's see if I... Yeah, that was the trick. Now I can solder it from this side. Okay, let me check. That looks okay. That looks also okay. Basically, yeah, wow, that was the one that can... That was the one that went to ground. It's not super pretty. I think that one. They all have contact. Right, the only thing here we have, but that's the bloody ground line. Don't want to touch that again. Here we have a few millimeters too much slack, but okay, I guess we leave it and see if it's still working. If you see SVR 129.99, I messed up. Oops. So, time for a scrub with the contact cleaner or IPA or alcohol, whatever you have. Yes, of course now not so easy as when we removed it, because I have to get past the torroid. Yucks. Okay, I guess it's time to end this. What time do we have? Okay. That is a 2-hour stream that nobody will watch, but it is what it is. I should have recorded it and cut it down into a 5-minute snippet, shouldn't I? Well, can you do that after the fact? Well, I guess when you have enough viewers, you can edit your live stream and, you know, make a highlights video. But I guess the person who recorded it could also download a complete video and cut it down to the essentials. So maybe I should try that. Compress this 2-hour fiasco. Oh, just kidding. Always a bit sarcastic. So, hooray, hooray, hooray. And flip it over. I think we can cut the remaining leads here on the bottom. One. And not lose it somewhere in the SMD component. That's also always annoying. So clean the bottom, and then it's hammer time. It's hammer time because I reprinted the sides and they're hard. They get a bit difficult to get on the first time. Mind you, I think I could do this. Let's do the test without assembly. I'll assemble it later, otherwise it takes another 20 minutes. So let's see. How bad does it look on a scale from terrible to disgusting? I think it has contact. This one goes here, this one goes to ground, and this one is, I think, don't know. Maybe that's a via, is it? I have to look at the PCB. So, right, I need this bit, and I need a piece of housing to avoid it shorting. So I think I need this one. This is my old black housing. Let's zoom out. Come on. Zoom out. Zoom out, zoom out, zoom out. Too much. Maybe like this. Double tap. Focus. Good. So, put it together and clip on the distance pad. So, then we need the dummy load. Where did that go? There it is. And screw it on. And then we need power to the people. And now the interesting question is, what are we seeing when I hit the PTT? Fantastic. Efficiency dropped from what was it? But maybe I have to tweak the toroids again after this. So we went to 3 turns to 21 turns, 3.5 megahertz, and we went down to 68% efficiency. Well, that was not the direction we wanted to go, was it? Small pause for thinking. What did we do wrong? I guess let's check a few other bands just for fun. Did not really help, did it? Maybe we fried around a bit too long with the let's go. Okay, right, that was not what we wanted to see. We wanted to see more efficiency, not less efficiency. Okay, then I guess I made a mistake. But gets nice and warm with the dummy load. I guess I'll double check my soldering once more. I think it looks okay. At least these two sides look fine. And this one, it's definitely correctly soldered. There's the 3 turns are really the one in a straight line. And the 21 are on the outside, so at least okay, but now let's think. What have we done? We have increased the inductance of T2, which is at the output. That means maybe we have to go through the whole efficiency tuning procedure, you know, squishing toroids and putting it into, okay, maybe the low pass filter should still be okay. I have to look at the schematic. Anyway, I'll move back to the computer and have another look at the schematic. That was a bit anticlimactic now. Let me switch to the other microphone. Let's have a look at the schematic and then I wrap this up. So that was a bit of a fail. Interesting. Okay, well, we went from 17 microhenry to something like 154 microhenry to ground. Which obviously should reduce the loss to ground because the frequency is shifted down. So why are we seeing different efficiency? Have I soldered badly? Or should I have tried the 1422 winding and a 0.5 millimeter wire? What time is it? Okay. Anyway, let's have a look at the schematic one more time and then we wrap it up. And here we are on the other microphone, which should probably sound nicer because it's a dynamic microphone. And the other one is a lavalier microphone. So let's see, where's my PDF viewer? Here is it. Then get rid of all these scribbles and have a look. So why would higher inductance to ground mess up our efficiency? It should improve, not get worse. Okay, let's see what we have on the output. Let's go to the 80 meter band. Oops, here. Okay, so here we have so what we've effectively done is this one goes through the relay to ANT, and from there we have the coupling. Well, there it goes through the one winding of T1, and then we have now the 21 windings to ground of T2, and then it goes to the antenna. So basically, yeah, I don't know. More inductance should be better, not worse. Interesting. Right. I think I have to investigate further and let you know. I also might want to try the two primary, 14 secondary winding. Okay, so that was not
That was not what I wanted to see, but it's also not what I expected, but it is what it is. So, oops. Yeah. Okay, I mean, simplest solution is I boasted too much about my fantastic enamel burning and soldering technique, and something got messed up. So I'll double check that and update the description if I found the problem or not. Okay, so stream is running for 2 hours, hooray. And we've just done the T2 mod and it didn't even work. Fantastic. Well, not a success, but at least I spent an evening tinkering and not doing household chores. So that's also a pro. Right, and the other changes I wanted to do was the OLED display mod. I'm fairly confident about that. Nothing should go wrong there. And the capacitor mod, yeah, I need to wait for the 63 volt film capacitors to show up, because the 100 volt ones, I think, are too fat to fit in. And yeah, my solution will probably look very similar to this then in the end. And I think he even replaced Marco even replaced the capacitors for the that are in the op-amp area. Yeah, so these are the 470, and I think there are 2 100 nanofarad capacitors as well somewhere, but that's for another stream. Okay, then right, so the pimping was not successful, but at least we had some fun, or I had some fun. Okay, then I end the stream, and until next time. And I don't know, I really have to work on my YouTube production techniques here, because nobody will watch a 2-hour stream, and it's mostly crap. So maybe I have to start doing this differently. Maybe I have to record it offline, complete stream, and then just cut it down to the highlights, or put a fast forward section in while I do boring stuff, and compress it down to 20 minutes or something. Okay, so everybody have a nice weekend, have a good week, and until next time.